Hey everybody, this is Larry. This is me doing week 2 of the premium weekly challenge or whatever it's called in April. It's a medium problem. Have we done it before? Oh, we haven't done it before. Yay! New problem for Larry. 255. Verify pre-order sequence in binary search tree. Given an array of unique integer pre-order, return true if it's the correct pre-order traversal sequence of a binary search tree. Okay, what does that mean? I didn't actually read the poem. Okay. I, 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 I didn't run today, but I did walk 10 miles. Some of it to record the video that hopefully you'll see. Kind of sad, actually, to be honest, because I have a pimple. I mean, I don't know what happened. I've been trying to eat more, but maybe I just ate something really weird. But I don't know. I don't know what any of that means. I don't know if anyone watching this. Ignore. Pretend I didn't say any of that. But it'll probably show up in the video. It is what it is. I'm not slick enough with like makeup or whatever. But anyway, all right, today's problem is 255, verify pre-order sequence in binary search trees. Okay, given a unique integer pre-order, return true is the correct pre-order traverse of a binary search tree. A pre-order. Okay, that's why I was like, wouldn't it just be sorted? But okay. So can it be pre-order? Okay, pre-order means that 5, and then all this will be on the left, and this is on the right. So okay, so I mean, I assume that this is true, so that's not that interesting. But let's see what happens with a fourth case. So you have 5, so that means that everything descendant, everything. So this is false because basically it's like a period in quick search, right? Quick sort, sorry. It's like the pivot in quick sort or binary search or whatever. And here you can see that you can really neatly partition them into 2, so that makes sense. Okay, so now that we have the idea about what we can do, what's the time complexity, right? When we do a recursion, the constant space thing is always a little bit tricky because not because it's tricky, but it's because people historically Leetcode's been kind of at least with the older versions, the follow-ups are kind of bad in that they don't count stack space and stuff like this. So it's always a little bit hard to tell whether we have to mind read them to like, oh, do you count stack space? Because if you don't count stack space, this is easy. If you count stack space, it's kind of hard. And it's just like, okay, well, look. One thing I want to think about is 10 to the 4th is kind of expensive though, because the thing with the way that I'm thinking about is with divide and conquer, right? So basically here you have pre-order, so this is the root. You recursively verify the left and the right, and you could do that with a recursion, right? But in the worst case, this is n squared, right? Because if everything's to the left, everything's to the right, then you just have n minus 1, and then no, I guess not. Oh yeah, okay, fine. Because we're not okay. I'm being dumb here. Okay, yeah, that should be good. I think. Okay, yeah. Because I think I was thinking about. No, wait. No. It's n squared, right? No. I am not dumb. I mean, maybe I am, but that's besides the point. Because basically, if you have to iterate the entire thing to partition left and right, then you're gonna like the recurrence is all of n plus 1 or n minus 1 plus n minus 2 plus n minus 3 ... and that is n squared. So how do you do this not in n squared? Because n squared with 10 to the 4th is a little bit expensive. 10 to the 8th is probably going to time out. Unless you want to guess that there's no weird solution, but that's or weird input, sorry, or like stress. If there's no stress tested inputs, right? But can I do this in linear or at least n log n. We can't change. I mean, the answer is yes. Can you wait? Let me double think. Let me have to think. I mean, maybe you could do n log n with like a really complex, data structure, which like if you, I don't even know if this is true. To be honest, I don't know if you can even do it. But I was gonna say maybe you could do some like currying with, but I don't even know if that's true. The only other thing that you can maybe take advantage of is that preorder sub I is 10 to the 4th. Oh. All the elements are unique. I mean, I don't think that changes anything actually for me anyway. Like maybe this thing we can use it to pre-index, like modify stuff. But like here, we can actually, now that we realize that the preorder sub I is less than 10 to the 4th, we can actually use a sec tree to kind of figure out to see if there's like a overlapping thing, but that is just ridiculous. I think you can also use a binary index tree in this case, because in that case you store the index of everything, and then you can maybe you can do a binary index tree actually. Was it prefix? Yeah, maybe not. But but you can use a segment tree to be like, okay, given all the numbers between these indexes, or yeah, like maybe you could. I don't know. This is a hard one. I don't know that I know how to do it. Is there linear time solution? Can I do binary? No, I mean this is linear. All right. Huh. I'll be very sad if the intended solution is supposed to be n square. To be honest. Which I don't know. I don't know if it is, but I'm really blanking out on the fundamental stuff. Or things from first principle, like very basic things that most people should be able to get. Constant space as well. Is there something that I need to know about preorder? Am I being dumb? Maybe I am being dumb. Let me think about it a little bit. Because I think I'm thinking about something else, right? Because preorder, yeah, okay. Maybe I was just thinking too naively with the divide and conquer. Because I think with preorder, you can just keep going, right? Okay, let me think of another principle then. Okay, let's say we okay, so I mean the divide and conquer thing definitely works, but it's too slow. So then now the second thing is, okay, let's say we have 5, so then now we put 2 on the left. We can do it by constructing the tree, and then we look at the next number. Next number is 1, so that means that's gonna be next, right? And then the 3. Yeah, I mean the one. How would I check this? 5, 2, 1, and then now left. Oh, well, the 3 cannot be under the 1 because that's what it would happen, right? It will be 1 on the 3 side, so then it has to go up to the 2. And then the 6. What happens to 6? It cannot be on the 6. It goes to the. It pops, and then you go to the 5 and 6. I mean, you could simulate it with a stack, I guess. But I mean, I don't. I think this is just like implicit stack or something. I don't know. How do I structure this? Maybe I'm just like being really dumb today, huh? All right. Okay, let's think about doing it recursively first, right? So then, okay, so let's just. I'm just playing around some more things, right? So basically what I want to do is, this is the first number. Oops. And now we want to go until okay, so let's say we have a stack. Okay, we have 5 and then we have 2 and then we have a 1. The 3 is greater than 1, so it would be on the right side. Like if you have a 1.5, the 1.5 would actually be under the 1, right? But because 3, then now we, how do I know to go back a little bit to put the 3 on the 2 instead, right? Do I do like a binary search on the stack? That sounds pretty hardcore, to be honest. But also maybe makes sense. Okay. And then what happens when I do put it with a 3? Then now the things that we can attach to is 1, 3, and 5. Now we have a 6, so then now the things that we can attach to is 1, 3, and 6. Then what? The next number. Well, no, because you have a 6, then everything else pops off. So when you have a 3, actually the 1 is no longer possible by definition of the preorder. So then now you have a 3 and a 5. You have a 6. 6, you binary search. So you replace the 5, and then now you have a stack of 6, and it's true. Okay. Let's say you have a 5, you have a 2, right? And now you have a 6. Well, stick now pops out, so then now you get a 1. 1 is no bueno. I don't know how to do this. Am I just being funky? Huh. Maybe today I'm just not very good today. All right, let's try the thing with the taking advantage of this, the range first, and then we'll see. And sorry, friends. Usually I'm pretty good at these fundamental problems, usually, but maybe not today. So, okay, how am I doing this? So maybe we go. Let's just call it. I don't know, fetch. I don't know, get, whatever. Let's just call it go. And then here we want to say, we want a bound, so then maybe lower bound and then upper bound, right? And it's unique, so I think we're fine. Okay, fine. Right, and then now, oh yeah, then we can just do return preorder, or not preorder, go of 0 and what is it, 10 to the 5th, whatever, infinity, right? And here, okay, and then we also get the next number, so we have to index 0 to 0, we will have to use it, right? And now here we get the first number, and then here the first number is if maybe something like it's good is equal to true, and then we just return good. Okay, so if preorder of index is okay, if this is in between lower and upper, then we're good. Otherwise, that means that something messed up and we have to return. Well, we just return, but we set good is equal to false. Otherwise, if it's good, and then here maybe we want to early terminate, so let's just do this instead, right? Okay, so then now this is good, so then we this is so yucky, but okay, we increment by, oh, not yet maybe, but yeah, then now we want to say we want to go this is not necessary that this is false, it's just that we don't consume it, right? So yeah, so maybe we just return, we don't consume it, because it could be on the other side or something like this, actually. Okay, so then now we have lower, we want to go to preorder of index, and also go upper preorder the other way around. We do want to increment index, so maybe we'll just store the thing down. Right, so now mid is equal to this thing, but we need to use this first. Sorry friends, this is kind of yucky. Okay, and then at the end we're good if index is greater than n. Okay, yeah. Also, I guess we want to say if index is equal to n, we return. We just don't have run out of numbers, right? I don't know that this is quite precisely right, but yeah. So we don't even use good. We just return whether index is equal to n, because then that's good. But I'm just gonna run it anyway, just to see what it would give us. Not super confident, but it actually went out. Okay, well then YOLO submit. Still not confident. Okay. Yeah, I didn't think that this would work, to be honest, but I guess the uniqueness matter. Because the idea here is just bracketing what can possibly be the left and the right, and then we kind of loop over all the possible places for we just loop over where the possible places are for the next item, right? I'm curious what the intended solution is. A monotonic stack. I was kind of saying about this idea, but it was just so, at least for me, to be honest, I just felt like this is so difficult to get. But I actually kind of, I actually was saying that there's, I was actually saying that we could binary search on this, which is what I was saying, but I don't know how they do it without the binary search. But I just thought that there's a lot of different cases. But apparently not. This code is pretty tight. Maybe I have to, maybe I should have thought about this more. Okay, so the constant space is, I guess, the same idea, but without explicit stack or something. I don't know. Oh, they're taking the input. Yeah, changing the input is kind of stupid. That's what I mean by, like, I don't know that I trust them with constant space complexity, because they mean something funky. I guess this is the one that I did, but it's a little bit. Oh, maybe negative infinity would have been better. I don't know what this thing is. But I did it in like a funky way instead. So, oh, this is really bad code. I know what they're doing. Basically, this is the way of doing it so that it's basically what I'm doing with the non-local index. But this is because now with an array, this is a reference, and as a reference, it allows them to do it this way. This is really bad. I actually hate this. Because that's just like a way to pass in this as a reference without doing it. But that's like really silly. We can just do non-local or something. I don't know. But yeah, but this is obviously, yeah, and stack space. So I don't know. That's all I have for today. That's all I have for this one. It already was a mess. I need to take a nap. So stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.